So hello everyone. So in my previous video, I've already told you about how to do the inverter schematics, layouts, and also we've seen to construct the schematic of two input CMOS, NOR gate, and also I've told you for construction of NAND gate what and all of the changes to be done. Okay. So in this video, I'm going to just show in the syllabus only it's mentioned one expression. Okay, that expression is AB plus CD plus E complement. Okay, for that expression, how to draw the schematic and how to check the waveform. Okay, the waveform checking and all it's not required. I'm just I'll tell you how to draw the schematic of this. Okay, and waveform checking and all that with the simulate with the including the spice code. I'm going to tell you how to check the waveform. Okay, so schematic part again, go for file, new library, give one library name as expression, cell, new cell, select schematic and write schematic, and here you will be getting the components related to schematic, and select grid here, that is press Control G for that connections would be easy. For here you see in the expression we have five components A, B, C, D, E. See these are five inputs. So in order to construct the CMOS implementation, we need 10 transistors, right? Since you know that if n number of inputs are there, 2 n transistors are required. Okay, that is 2 into 5. That in this case it is 10, 5 PMOS and 5 NMOS transistor. Okay, so along with that we need one VDD, one ground, and one output. So let us construct that one by one. First is PMOS. We need 5 PMOS transistors. Okay, so this is one. So this is one more. I'll rotate it because in order to make the connections easier. So 5 PMOS and we need 5 NMOS. So along with that we need one VDD, one ground, and 5 inputs, and one output. Okay. So these many things are required. So in the expression is AB plus CD plus E. So in the PMOS part, you see that AB they are multiplied. So in the pull-up part, the PMOS transistors would be in parallel if they are multiplied, and the NMOS transistors would be in series in the pull-down part. Okay, and it is added with CD, AB plus CD plus E. So if in the for addition the PMOS would be in series, okay, and for addition the PMOS would be in parallel in the pull down part. Sorry, the NMOS would be in the parallel. Okay, so these are the things here. So before doing the connections, I'll just uh, set spice model for each transistors so that afterwards we do not be left with any task. Okay, first do that. Tools, simulation spice, set spice model. So this is PMOS. Along with that, 10 is to 2. First, I'll give this as 10 is to 2 for all transistors. Now, set spice model, select each of them, tools, PMOS. these are NMOS. So this only takes a lot of time, guys. So yeah, everything is done. Now just export all of them. That is, this is Control E. This is power, VDD. So this is output. So I'm giving it as Y. So this is ground, G and D. So these are five inputs here. First one is A. This is B, C, D, E. Okay. So now everything is done. Now the connections. Okay. So just align this. These two are in series. No, no, wait a minute. Yeah. So now let's do the connection. So these two are in parallel, right? So this whole combination is in series. Then here these two are in series here. This whole thing are connected parallel to each other, right? This ground and here also. Then from here the output. So this part, the connection part is done, guys. Now the inputs here, that is, this is A, right? So this first PMOS transistor and first NMOS transistor should be connected to A here. First, let us do that. So A is done. Now for B, the here the B is here since these two are in series. So this is the B. So B connection is done. Now for C, so here this one is C here. Now for D, so this one is D and here this one is D. So this is D. So D is connected to D. So here final one is E here. And this one, okay? Just observe very carefully while connecting for which one you are connecting, okay? Don't overlap with the other lines, okay? So this is the, in this way, if they give any expression, the CMOS logic connection you should be doing, okay? For separate inputs. So here we have five inputs A, B, C, D, E and one output Y, okay? So now everything is done. Now let's check for whether we have any errors or not. Tools, DRC, check hierarchy. So there are 12 errors. So let us see which are those errors. So like this, the errors you would be getting, guys. So one by one, if I try to fix these errors, I would be taking a lot of time. So what I'll do is I'll just skip this part. Okay. So checking errors and all. So this what I've just done is the since there are many wires which are overlapping to each other, right? So that's why it is not considering as correct inputs here. So that's why you should be checking for each inputs very carefully and try to check for errors. Okay. So see, the second error is here. So this is the third error. So this is one unnecessary pin here. So here what I'll do is 11. So like this, one by one, you should be correcting all of them. Okay. So now see only one error is left. So that is here. So there were double lines. So now I guess the errors are over. All the errors you have checked. So now again tools, DRC, check hierarchy. Yeah. So now we don't have any errors. Okay. So like this, the schematic part is done. Since there are many wires overlapping, right? So that's why you would be getting a lot of errors. So now again for spice code generation, go for miscellaneous, select spice code, double click, control I. Here you should be writing our, click on multi-line text, and here you should be writing our code, that is expression. So like this, the code again, no change here. The same here we have five inputs, right? So we should be declaring five separate lines for inputs, and rest all the things remains the same. two input NOR gate. Okay, so this is the spice code, 0 to 5 DC voltage, that is the range of the amplitude range DC, that is 0 to 5, and for all the 5 inputs different intervals. Okay, so this is the spice code generated here, and to check the waveform you should going for tools, simulation spice, and write spice deck. Okay, so after that you will be getting our LT spice waveform. Okay, you should be going for LT spice and checking the waveform. So that's all for this video, guys. Hope you understood how to create the schematics and all, and you would be understanding well, and if you work out these things very carefully. Okay, so that's all, guys. We'll see you in the upcoming videos of the theory classes. So from my side, I've done my level best to provide the most of the lab experiments. Now it's up to you to learn these things. Okay, so that's all, guys. Thank you.